Welcome everybody to this third webinar of a series of 5 covering upgrade economics and myth busting for Council Aquatic Centre upgrades. My name is Jared Leake and I'm the CEO for the Australian Alliance for Energy Productivity. I'd like to begin this webinar by acknowledging the traditional custodians of country throughout Australia and their connections to land, sea and community, and pay my respects to their elders past, present and into the future. Just a little bit of housekeeping as we get underway. This presentation will be recorded and the slides will be sent out to those people that have registered. At the end of today, we certainly plan to have a good session of Q&A. So get ready with those questions and feel free to put that in that Q&A box down the bottom there and upvote anyone else's question that you like. So yeah, get ready with those questions. We've got an excellent panel here for you today. A really good opportunity for you to learn more about upgrade economics. Just a little bit about A2EP. We're an industry association focused on energy productivity, which is all about getting more value out of less gigajoules, less energy. We've got a wonderful set of members that fund our organisation, and it really crosses a beautiful cross-section of researchers and equipment suppliers, energy suppliers and the like. And it's thanks to this support from these members that we're able to bring you webinars like this. Joining me today as part of the A2EP team, I have Brendan Voss, our project manager, who's looking after a large research stream related to heat pumps, as well as Alan Pears, technical advisor to A2EP and RMIT industry fellow. Welcome, Brendan and Alan. We've got a lot more speakers for you as well, and I'll introduce those to you shortly. Just a little bit more on A2EP and what's available out there already. We have a series of webinars and documents and tools for you on our website. If you go to a2ep.org.au/aquatic centres, you'll see a whole series of documents and resources there to help you with that upgrade of your aquatic centre. Most people here today already know how important aquatic centres are as community assets. They already probably know that's the largest energy user, especially when it comes to natural gas, and probably the largest source of carbon emissions. And with so many councils looking to reduce their emissions, this is number one on the list. And thankfully, there is support coming from the federal government to help with this transition. As announced just recently, this program is looking to be open in January next year. There's $100 million available. It'll be split between 2 rounds, open this January and January 2025. And this is for you to get co-funding for your upgrade project. And that could be upgrading your heat pumps, installing some lighting at sporting fields and what have you, and of course, energy efficiency upgrades. And as part of that fund, A2EP and Sustainable Business Group what has been asked and is being commissioned to carry out a capacity building program. This program started in October, and we start, of course, by listening. We got together, I think it was about 15 or so councils in a location down in Melbourne. We had councils all the way across from Victoria and New South Wales. And we started listening to the issues and capturing them in the good old way of flip charts and whiteboards. And with that, we're able to distill down what are the key issues that councils need help with in terms of guidance. And we certainly appreciate there's often a large asymmetry of information between councils and contractors that are doing these sorts of upgrades every other day. And so it's our job. We're trying to bring the latest of best practice and the best way to do these projects and share that with you all. And hopefully that helps you guide with your upgrade and what have you. So as I mentioned before, we have 5 webinars. The first one we did was on case studies, and that's what we heard loud and clear from that workshop. Tell us about other sites that have done electrification. So we had 3 great case studies for you. 2 of the presenters are returning for us today, and we've had very good feedback to say, wow, didn't realize electrification can and is done so widespread. So that certainly gave people a lot of motivation and confidence that electrification is possible and here and now. Last week, we had our second webinar that looked at templates for getting a feasibility study. Often that is your first step, getting a feasibility study done along with metering and what have you. And so we gave you a presentation there, and these are both up online. You can get those from our website or straight from YouTube. And so both of those will a great starting point for you. Today, the focus is on energy upgrades and looking at the big costs and how we can impact that. Next year, we're going to be looking at a bit of a deep dive when it comes to heat pumps, and also then helping you with commissioning and operation of your heat pump for ready for when you get that installed, hopefully next year. So just to give a little bit of a framework around this and what we're talking about here today, this is a rough case that we want to present to you. And so we wanted to show you a few scenarios of how you can really move the needle on the economics here. And so if you looked at, say, a 1 megawatt heat pump, maybe that'll cost about $1.5 million. I appreciate that. That's quite a wide band of where that would be, but that's what I've heard is not a bad amount. Let's say that was operating for 6,000 hours per year and partial load of 50% and a COP, coefficient of performance, of 3.5. That would give you about 850,000 kilowatt hours per year of electrical consumption. And at 20 cents per kilowatt hour, that gives you about 1.7 million of electrical costs over 10 years. And so certainly a heat pump is a high capex, low opex sort of a way, and that's very different to existing and incumbent boiler technology. And so we thought of let's have a look about the economics. How can you make 1.5 million maybe down to 1.2 million for the capex? How can you make 1.7 million electricity? Can you get that down to maybe 1.2 over 10 years? And I thought let's go through and see different ways to do that, and especially things like how can we avoid an upgrade of the electrical capacity, because that will take a $1.5 million job up to possibly $3 million. And so we're going to start there today, actually, in ways that you can do that with energy efficiency. This is my lovely panel here today. And we have Stuart Darragh from Enel, Felix Silberstein from AGL, Grant Raja from Northmore Gordon, Alan Pears from A2EP, and so is Brendan Voss. And then we're going to get presentations from each of them. And then we're going to have a nice panel discussion from our council experts that have lived and breathed aquatic centre upgrades. And that's Laura Carey from Inner West Council, David Collins from Brimbank, and Liz Locksley from Canada Bay. And so we'll be hearing from them shortly, or hopefully they'll have some questions after each one of the speakers. So to kick off today, I'd like to introduce you to Alan Pears. Alan Pears is our technical advisor or thought leader, if you will, at A2EP, and is also a fellow at RMIT. Alan, I'll get you to start sharing there. Alan has worked in energy efficiency for many, many years, really done fabulous work with promotion of programs like Neighbours or design of them, and things like energy efficiency opportunities. He's been a great supporter and presenter for A2EP for so many years. And Alan, lots of insight here to share on aquatic centres, so over to you.
Thanks, Darragh. I'll skim pretty quickly through a few issues that I hope are relevant for people thinking about their business cases and financial analysis. Don't forget the slides will be available later on, and the audio, so we can come back to issues later. So I'm going to look at some of the issues like climate change, electricity structure, infrastructure, multiple benefits, and what kind of indicators you might think about using. So firstly, if we start off with carbon, anyone who's doing modelling for a long-term asset needs to incorporate carbon pricing into their financial analysis. Unfortunately, it's a bit difficult to know what price to use. So I thought I'd show two examples where the European carbon price at the moment is over $130 a tonne of carbon, whereas in Australia, the Australian carbon credit price is only about $30 a tonne. Pretty clearly, this will have a big impact if you're still using fossil fuels, or alternatively, you can frame it so that by decarbonising, this is how much you can save. Also, it's important to think about how we account for carbon emissions And most businesses and organisations typically have been focused on what we call Scope 1 and Scope 2 emissions, which are directly controlled by a company. The Scope 1 are the gas and the petrol and diesel and things like that, methane emissions. Scope 2 is the emissions associated with electricity or heat that you import to your site. And Scope 3 is basically everything else. And in particular, these are the issues that your organisation influences but doesn't control. And a lot of councils are really already focusing on Scope 3 because they're talking about reducing carbon emissions of their communities. So when you're thinking about something like an aquatic centre, you should be thinking about the carbon emissions from people accessing the services that you're providing, embodied emissions in materials, what your contractors' carbon emissions are, and the consumables over the life of the facility. These are all relevant to Scope 3 emissions. On the electricity supply infrastructure space, if you've got high peak demand, particularly in winter, which is where the peak demand of most aquatic centres is, you are going to see much higher costs associated with electricity supply, including needing to possibly upgrade your own electrical infrastructure as well. Also, a lot of aquatic centres have what we call a poor power factor, which increases the wiring losses as well as impacting on the life of your equipment. And I'll explain what a power factor is a bit later because not many people seem to understand it. On the positive side, aquatic centres have lots of thermal inertia and lots of energy happening. And so they're in a good position to shift electricity use, increase it or decrease it, and to capture revenue in emerging markets, which others will talk about today. A lot of people focus on the price of generated electricity. This is some work from a transmission company that looks at the retail cost of electricity over a range of scenarios out to 2050. And the dark circle, oval, shows you that in fact, for most retail consumers, it is network charges and distribution and transmission costs that are the dominant component. So this is why we're obsessing about peak demand and being able to shift it and things like that, because minimizing the cost of all of that infrastructure will show up big time on your energy costs. And we have to keep in mind that while aquatic centres usually have peak demand in winter, that's just when your rooftop solar is delivering least. Now, just on the power factor, it's a funny kind of thing, but the idea when we have an AC, an alternating current circuit, is that ideally the voltage and the current should be going up and down in a nice smooth cycle, and they should be in phase with each other. They should be matching. And that's a power factor of 1. But what happens is that they start to move apart in time, and that then starts to create inefficiencies. So the example I give to show how to deal with this is a person pushing their grandson, like me, on a swing. Because what happens, if you think about it, if you push the kid at the right time, they get a high swing and you use least energy. If you try to push too early or too late, you have to work harder and they don't swing as high either. Well, that's wasting energy. And that's what happens with a poor power factor. And that impacts not just on the wiring and things like that, but it can impact adversely on the life and the performance of your equipment as well. So it's quite an important issue. I won't go through these other notes. You can read them later. Also, a very important thing is the multiple benefits of the energy strategies and carbon strategies you apply, because basically the International Energy Agency and lots of other people have spent a lot of time explaining that the value of the multiple benefits that you capture through smart energy use and carbon minimization are worth much more money than the actual energy savings. Also, they're much more tangible, and so they're much more likely to press buttons with key stakeholders if you can explain how these kinds of measures will achieve things that they value. I mean, we did this recently with the food industry where they were concerned about loss of food, and refrigeration and energy were really big there. Well, another key thing to think about is how you do your financial modelling. And one of the really big problems we face is that a lot of people use what we call a simple payback period, which is essentially how long will it take me to get my money back? That is psychologically really negative and really bad. Because the reality is you are making an investment that is actually delivering a return on the capital you invest every year, which is why using an internal rate of return, which you can compare against your cost of capital or what kinds of returns other investments might make, or you can, well, and you can use net present value, which gives you an estimate of the overall lifetime impact. The other key thing to keep in mind is the discount rate that is applied. Many accountants quite like to use high discount rates to focus on the time when their contract is in play and they can look good. But the problem is a high discount rate means that you are ignoring the value of the benefits that you've invested in for much of their lives. So for example, if you use a 10% discount rate, by year 10, you'll only be valuing the benefits that you're getting from your energy savings at about a third of what they have been when you started, and really they're still going to be important then. So it's very important to get a low discount rate applied to a long life asset. I've already mentioned multiple benefits as being really important. And again, a lot of the time that people don't bother to quantify these because they might be a bit hard, but it's really important to do your best to quantify them and emphasize their existence and how they link to what we're doing. This is my last slide. And really, it's just starting to talk about some of the myths and understandings. And one of the key issues we have is that, oh, heat pumps don't work in cold weather. Well, if you actually look at the laws of thermodynamics, what you'll find is that the thermodynamics of heat pumps actually works from a temperature pretty close to that of outer space. That is minus 273 degrees Celsius. So in that context, minus 20 degrees Celsius is actually quite hot. So there's plenty of energy there. It's just that we get confused between different indicators. At the same time, it's true that the bigger the temperature difference across a heat pump, the less efficient it is, and also that around 0 degrees, you can get icing up problems. But the reality is we can deal with all those things. And of course, we get incredible efficiency and we can get heating and cooling at the same time. And again, some people are skeptical about the lives of heat pumps. And I just point out, well, how old's your fridge? Mine's pretty old and it's still going fine. And it's about quality product, well managed. And again, there's a whole lot of debate about refrigerants. Some of it's really important, but we can manage it. There's a lot of conflict driven by competition in the industry. So with that, I'll finish. Thank you.
Thank you, Al. I'll get you to stop sharing there, but absolutely hearing you there. So energy efficiency and things like power factor, that's looking at reducing that. Not only is there the electrical consumption from it, but also that could help you avoid triggering that transmission upgrade, which is extremely expensive. So also heard that multiple benefits. If you can bring that into your business case, that really gives you quite a lot of leverage. And I didn't have that on the agenda today, Alan. Evaluating the cooling as well. if you use the heat pump to cool the gymnasium, that's a pure savings there as well. And I think they're doing that at Brimbank Council. Got a big nod there from David. So that, yeah, again, a great tip there, and love the financial framing to say, like, don't start from a negative point from payback. Think about this in a much more positive way and getting a good discount rate applied. Beautiful. Thank you, Alan. Just check if our council people have any quick question there. No one's coming off mute, so we shall keep moving. So looked at electricity impact there from Alan, saying looked at electricity supply. Next, I thought let's take another big one that can move the needle a long way, and you could be looking at, with white certificates, potentially up to 20, 30, maybe more than 30% of the capital cost as something of a rebate using white certificates. So let's hear from the experts here, Northmore Gordon, and we've got Grant Raja here. There's the principal consultant at Northmore Gordon. Grant knows certificates, he knows energy efficiency, knows how these applied. And so, Grant, over to you to take us through how these sort of the white certificates can be applied.
Yeah, so terrific, Jared. Trust my screen's up and running. Yep, all good. Cool. So good afternoon, everyone. So quick introduction. So Northmore Gordon has been a leader in the environmental certificates markets for many decades, and we also support that with a full energy and carbon advisory service business. So today, as Jared said, I really try and help you understand how to leverage the white certificate market to improve the business case from your project. And to give some context to that, I really wanted to call out for this discussion 3 really common ways you as a council can improve your business case. And the first one might sound obvious, but even listening to Alan's conversation about understanding the multiple benefits, it's really plan for success. And I'll talk a little bit about that. Then before we talk about the actual revenue of certificates, I wanted to highlight for many the risks and opportunities out of a volatile energy and certificate market. And lastly, really to this other point of driving success is about beyond the project, look at how you can optimize results. So, and just to quickly note, Northmore Gordon's been working both directly with end users and service providers. We've created about 6 million white certificates worth over $150 million for our customers and service providers. So jumping into, yeah, and this slide sounds obvious, but it's actually the hardest part, to be honest. It's really understanding to get a successful project, have a strong, not just technical criteria, but a financial criteria. And Alan touched on the importance of having that before. The second point that I'm just going to go into a little bit detail is in the webinar 2, we talked about designing the right size of heat pump. I'm going to talk a little bit about understanding how price changes can also impact on the success of a project being approved or not. And we'll talk about leveraging certificates. The key point I was trying to get from this slide is if you start with a good plan, and I heard from one of the councils last week how early they engaged with their finance team, what I hope you can achieve out of this project is a blueprint or a model for confident investing to do a lot more than heat pumps. And the key thing to think of when we're trying to demonstrate the value of the business case is the diagram on the right that talks about what is your energy load today, how will the project actually make a difference, and how are you going to measure the results. So the white certificate program really gives you a methodology for showing finance, showing stakeholders how you're going to measure the results. And just to sort of emphasize a point Alan made, truly think of the project having more benefits than just financial, emissions, responding to lowering risk, and I'll talk about the certificate revenue as really additional revenue to your project. So one key thing that's been talked about a couple on these series is how the energy market has changed and how it's creating a really good business opportunity for heat pumps. The key thing I wanted to highlight here is price volatility as it currently stands will change your paybacks quite significantly. And for some businesses that may be seeing softening in gas prices, softening in electricity prices, there may be an extension of simple payback. But overall, when you step back from all of this, we've really reached a cutover point for heat pumps. They're just more effective at generating hot water than traditional gas boiler systems. And the takeaway I wanted to give you on this slide is when you look at that sort of converged point in the diagram of where you might be paying above $20 per gigajoule and you're paying close to 20 cents or let's say $200 per megawatt hour, the modelling is showing, and this is even a few months old now, that simple paybacks can be less than 5 years. And I've seen projects that are obviously a lot better than that. So the takeaway here is price volatility in electricity, gas is a risk that you can be informed on. The second part, which I've just touched on the right-hand side, is even the revenue from certificates. For those that are already looking at it, depending on how you contract and how your service provider manages the additional revenue, that certificate price could change dramatically. Many of these schemes are affected by forward government policies. So it's really important, once your business case includes the value of additional certificates, is to understand how your service provider is managing this risk. And we can come back to that in further discussions if it's of interest. So this next point is really to understand what sort of certificates we're talking about. So many on the call will be aware of renewable energy certificates, potentially have talked about carbon offsets. White certificates are what we're talking about here, and they're focused on energy efficiency for this context. The two most common schemes in Australia are the ESCI schemes in New South Wales and the VEET scheme in Victoria. And if I just scan back, just to put those two in context, the energy savings value of effectively a tonne of CO2 in Victoria is currently sitting at $87. Now, the energy value of a ESCI is sitting at $30. It's quite a big difference. But these are most commonly the main white certificates people are using to value energy efficiency projects. The next key couple of points here is that you have to understand the rules of each of these schemes. They are different by region, by timing. I'll talk a little bit about the verification methods. And two distinct features of white certificates that's quite unique is that this term of forward creation of the lifetime revenue. So I'll explain that in a case study, but it basically gives you the ability to bring the revenue of on the project. Jared talked about it being up to 20 to 30%, avoiding the capital costs. Some cases it's deemed, some cases it's realised after the first 12 months, but it provides a really strong financial benefit. The second one that's often talked about with heat pumps is white certificates enables you to integrate multiple energy measures. And in this day and age when we've got to do bigger, more significant greenhouse reduction projects, a really big call out is the synergy between solar and heat pumps to improve the overall impact. And last key point here is, if you're not familiar enough with white certificate programs, a simple action here is to talk to, during the feasibility study, understand what megawatt hours are being saved, multiply that by the market prices that I've shown on the earlier slide, and you can get an estimate of the potential additional revenue. This next slide is a case study, just to sort of put it into context. So it's a Victorian swimming pool. They've implemented heat pumps with solar, other energy efficiency initiatives together to get a really significant VEET benefit that added more than 300,000 additional revenue to the project. So significantly more than 10% of the capital cost. And they saw that benefit after the first 12 months of the project. Now, one other aspect of understanding white certificates is the methodologies differ for different technologies, different certificates. So focusing on the right-hand side, the two things I want to call out is some projects will choose to use a deemed methodology, which you might be familiar with. Light upgrades are commonly used. I think the shower head schemes in New South Wales use deemed upfront mechanisms, and then more detailed project impact assessment models, or the baseline method, are more robust methods. And the key thing to understand here is some organisations will use the deemed method by default when there's not enough data in the project. So a call out to good design is, if your project is significant and you're capturing a lot of savings, putting metering into the project enables you to capture those more complex measurement and verification models like project impact assessment and baseline. And the benefit of that is twofold, which I'll talk about later on. But the key thing I wanted to call out here is, if you rely on the deemed method, it has a significant discount, and that's partly due to the uncertainty. So we can talk about that if needed. Last two slides, really, what's the process if a council is interested in capturing the white certificates? So assuming you're working through a feasibility project, you might be currently at the final phases with a service provider. This is definitely the time to make sure that in your multiple benefit assessment that you're capturing additional revenue. When you decide to go for the certificate revenue process, the common steps are listed on the left. Someone needs to be appointed as the upgrade manager, and that has to be an accredited person like Northmore Gordon. There's a eligibility and nomination process. The regulator will need time to review all that, and could take up to 6 weeks to have the project approved for the white certificate scheme. From that date, once it's approved, implementation can proceed. The job of this upgrade manager is then to cite independently all the evidence, document it. A audit process is commonly conducted. So if we're doing it, we will go on site, validate the results, and then we can complete the process to create the certificates. And just to call out some things that I think are really relevant, this whole process of establishing the methodology is in parallel to some requirements around a peer review. It gives you, the second one I call out there, it establishes that pre-upgrade baseline, and the outcomes you're getting when you choose a provider is a certified measurement and verification professional sign-off on the project, which becomes, this is one of my last couple of points in the presentation, is it gives you as a council confidence that the project has achieved its results. So takeaway here is metering and measurement and verification really can enhance the value of your project. And last slide, if closing, the key point is today heat pumps are really the new low-hanging fruit. But when you look at the projects and you look at the opportunities to limit, or the requirement we all have to limit global warming, we need to do a lot more. And so my takeaway message here is, when you're trying to build a business case, the certificate schemes can really help you fund larger projects. It gives you the reason and also opportunity to put metering in place. And then, as many other people have already said in previous seminars, having the data from the meter optimizes performance. It builds confidence. It enables you to confidently report to your stakeholders. And my really last best wish to you all is that if you have a strong business case that's showing results, your stakeholders and finance people will want to invest in more projects. So thank you very much.
Yeah, brilliant. Thank you so much for that, Grant. And yeah, loud and clear, metering. And to add that to that, for those in New South Wales, hopefully there'll be a grant program open very shortly trying to support you to install that metering. That'd be a nice little help. We also covered that a little bit last week when we looked at templates for looking at feasibility studies. There was a bit on metering in there as well, but absolutely hearing you. One comment there, Grant, on the deemed method there. I understand that there's not so many approved products in the space that like the one behind me, large enough maybe for aquatic centres. Apparently they're coming, but usually the deemed ones are in the sort of maybe 10 to 30 kilowatt range, which most aquatic centres need something much larger, but apparently they're coming. So easy to understand. So deemed, it's easy to get them, but at a lower rate and only smaller ones at the moment.
Exactly.
Good. Just checking if there's any comments. Yeah, Liz, would you like to a quick question there for Grant?
Yeah, I've got a quick question, which is, well, we had a bit of a lesson learned from our heat pump installation in that we didn't have interval metering for our gas meter, so we were going to have to do the project method. We didn't have enough data. So, can you just explain quite practically what kind of metering people are going to need and how much data they're going to require, because that might set quite a lead time in terms of if you need to install additional metering and collect data.
And I'd answer that with a caveat that it also depends on the size of the investment you're looking at making, right? So if you're making the decision that the certificate revenue is material, then in an ideal world, I'd be advocating that metering goes in immediately, start the feasibility process. Yeah. And so I think even in the previous seminar, Jared, there was conversations about installing one sub-meter at the point where the gas load was, installing that relatively quickly. Someone, if I use the seminar from last week, it was a $7,000 investment for a interval meter giving SIM data, so it was communicating to share the information. But you honestly want 15-minute interval data from that meter. You also want it separately to be able to, in this case, read the gas load for the boiler.
And how many years worth of data? Like we were advised by one organisation that we would have needed 2 years, so we didn't want to delay the installation of our project by 2 years. Just
a good practice would be 12 months, but even when you allow for the start from feasibility and you've got it through one winter season, then you'll have a good baseline. A good part of the feasibility study, and it really depends on how fast your approval processes can be, but that's why the suggestion was made to install it as early as you can. And one of the key things I was trying to convey in this whole discussion is once you start down this path of trying to use meters to create white certificates, your other business case is you should have better metering across your sites wherever you can afford it. And so think of the cost of adding 1 or 2 meters as an incremental investment across your sites as you expand on projects. So I wouldn't think you need 2 years. That's nice, but you wouldn't need it. And the feasibility study can do some engineering to evaluate your baseline. And what is needed is a good meter for the period before installation to give you some live data. And then as that graph showed at the beginning, you've got a solid baseline, you can show the scenario, and then you're projecting the actual performance.
If I can add to that, then Grant, often the bad news is if you're doing a retrofit project, quite high costs. The good news is if you've got good metering data, you can more accurately estimate the heating demand, and so you can size your equipment without that sort of fat or overhead that you may normally have in there. And when it comes to white certificates, David, you couldn't get that for Brimbank. That was a completely a new one. Laura, I think I'm not sure if you're planning that for your next upgrade there at all. Is that on the cards for you with the metering in place?
It's definitely on our radar, but we don't have interval metering on our gas, so it's something that we'll have to look at sooner rather than later. But definitely interested, and I also just wanted to clarify with one of the providers, like what changes in a retrofit upgrade would mean that it can't be. For example, Bringback was a completely new system, but I think there's something about if you change floor area or something, you might not be able to claim. So I just want to get that advice at some point as well.
Yeah, and that just touching on the methodology. So when I talked about the baseline method versus the project impact assessment, if you've got a complex site that's changing operations, the consultant would give you advice on how you could isolate the load with a project impact assessment model. And in those cases, you definitely want metering to isolate your load. You're in New South Wales, aren't you, Laura? Yeah,
That's right.
Yeah, so Gemna actually has a program for gas metering. Yeah, but it is an expensive 5 to 7, 10 grand kind of investment per installation for gas
Yes.
metering. So
yeah, we have approached them previously about adding an interval meter, and I think both of our large sites sort of just teeter on the large market threshold, so they wanted to think about it, whether or not they would invest in it. So maybe the alternative of us paying wasn't something that we realized we could do. That's good to know.
I think, by the way, metering, a good, great investment there. Okay, let's keep moving, and we have an excellent question from Matthew here, which leads us perfectly into our next speaker. Matthew is asking about flexibility and the ability to participate in front of the meter opportunities, like demand response has been considered in business cases. And Matthew, thank you so much, because that leads us to our next speaker, Felix Silberstein. Felix works for AGL, and he's a strategy manager for their commercial and industrial customer business, and leads the electrification work stream. And I've been working with Felix for the last couple of years, and I see that AGL is working very hard to try and help with this electrification transition and getting understanding and support for customers to best do that. Felix, over to you to take us through what AGL knows about and how it can help you.
Yeah, thanks very much, Jared. And thanks to the other speakers as well. I'm going to talk about minimising lifecycle costs. There's obviously been a lot of chat already about some of the considerations that you want to make when you're designing a heat pump, and these are all valid. This is more focused on the sort of energy and capex balance, but certainly all of the considerations are sort of things that you want to be considering, so worth keeping in mind. I'll start off just giving a bit of context on energy markets, and then talk about the cost stack of heat pumps, and then how that sort of affects design decisions, and sort of what to think about, with a couple of examples in the end there. And yeah, Alan noted on the energy point. I think as I go through, it'll become clear that what I'm talking about is not exclusively the energy component, but your energy bill is made up of all sorts of things. Getting into it, so energy market, the NEM in particular, for this purpose is in transition. We all know this. It's sort of moving from a baseload and peaking generation system to something with a lot more renewables and firming to support the intermittent renewables. When those renewables are available, they're putting downward pressure on prices, and when they're not, we have to meet demand, a big gap in demand as baseload comes out with more firming generation. One of the things that's sort of driving is additional volatility in the market, and sort of a change in the load shape as well. We're already well and truly familiar with the duck curve, which is that hollowing out of daytime prices because solar is coming into the market. And I guess that the point here is that you can use this to your advantage when you're thinking about designing a heat pump to get some flexibility in, and only use power when it's sort of less available, to minimise your operational costs. So in terms of the cost stack for a heat pump, we have here a sort of cost stack that I've pulled from the A2EP heat pump estimator. A little plug for you, Jared. And you can see that the overall cost life cycle is less than the existing energy spend on gas in this case. You're getting your payback period, or you're getting a payback over time if you start thinking about that IRR and the sort of a life cycle value, the present value of the project. A big chunk of that is the capex, as Jared sort of pointed out. The big chunk is capex. The heat pump being the most significant component, and then adding storage can cost a little more. But energy is still a significant component of the overall cost stack. And that energy chunk is going to be made up of your energy, your network, renewables, and some other costs as well. I've already spoken a bit about the energy market and the volatility there. And so you can imagine that the load shape and the level of flexibility you have is definitely going to impact how much you pay for the energy component of that bill. Network, again, if you've got a demand charge or a time of use tariff, there's going to be some opportunity to reduce the costs with a level of flexibility. Renewables are sort of more about the percentage of your bill that you're looking to purchase through a sort of green programs. There's additional costs that you could incur there, but there is sort of an increasing trend in energy and sustainability spaces to think about grid intensity. And so, if you're not optimizing exclusively for cost, you may also be thinking about the grid intensity at a given time, when there's more renewables or more fossil fuel-based generation. So that's sort of another thing to consider. The other one we won't dwell on because it's not such a significant component. Another reason why flexibility could be important as well is all of these costs have a demand component, and so the more consumption you have, the more you're going to pay. If you're using if you're able to operate more flexibly, you can use the fact that the daytime is warmer and heat pumps will operate more efficiently in that daytime period, and that could help you to reduce demand. And you can also increase your self-consumption, which is, again, a great way of decarbonising and reducing your overall operational cost. The reason why there's a sort of consideration at the design point and why you want to start thinking about this from the start is because the level of flexibility that you have is going to be constrained by the capacity and the level of storage that you have, and also and how that interacts with the ability to operate flexibly. So you're constrained by a heat load. You need to keep patrons comfortable in an aquatic centre. You don't want to be ramping up and down your heating and cooling to sort of minimise that cost. You can sort of decide to increase the level of storage and adjust your operation as a result of that. But it's a trade-off between CapEx and OpEx. It's sort of illustrated in these three hypothetical cases that I've put in here. So in these three scenarios, on the left, we've got the 2 days of operation, just for sort of an example, and then on the right, the implications for sort of cost. In case one, the system's been sized for capacity, and this is something that Jared will tell you straight away, don't do. You can get away with, you can do better. And in that instance, you've got no storage. You've got to follow your heat load consistently. So there may be some room for wiggle room, but you don't have much flexibility. You can't move your heat load around. And you're also sizing the system, the most expensive component, CapEx component, as large as you need. So this is sort of worst case scenario, really. At the other end of the spectrum, in case 3, we're looking at minimizing the size of the heat pump. So what's your load? How low can we go to meet demand in all intervals, with enough storage so that our daytime load or whenever our load is coming through, so maybe like morning or evening, is covered by operation in other intervals. And that just means that you need to run base load flat out. And again, you've got limited flexibility in terms of responding to other price signals or whatever it is that you're optimizing around, meaning that again, you're going to get sort of a higher energy cost or not be able to achieve another goal that you might be optimizing for. The central case, where we've got sort of somewhere between the maximum capacity and the minimum capacity, and we've got somewhere between the amount of storage we need for that minimum capacity and sort of no storage, enables us to operate a little bit flexibly. So we can ramp up when prices are low, or to sort of meet load, and we can operate a little bit higher than we need, filling up that storage and then discharging when the price goes up, and then we can sort of ramp down in those high price intervals. The outturn of that is this cost implication stack. So you can see case one, as I said, highest cost, and then case two, lowest cost, but the second highest cost in terms of capex, and case three is the sort of intermediate but sort of lowest capex. So when we start thinking about life cycle cost, you can see that thinking about this sizing becomes much more important. I should note that second case wasn't optimized here, so you may even be able to get a better outcome than this. It's just sort of to illustrate the point here. I think that's sort of the main points that I wanted to make. But just to summarize, when you're when you're sizing a heat pump and storage system, when you're sizing one of these projects, there's a massive you're making a decision that will impact the capex, but it'll also impact the level of flexibility. That flexibility is going to have implications for your OPEX and will enable you to sort of operate to increase self-consumption, maximize your efficiency, minimize the emissions or minimize cost overall, minimize your price exposure. And that sort of could be significant in terms of minimizing the overall cost of the project over its lifetime. Something I haven't spoken about yet, but is worth mentioning, is that smart controls can sort of support this. They help that optimization. They can link you up to markets and get sort of more reactive operation, linking into VPPs and so forth. And then finally, we've spoken about it a few times. A few people have spoken about it, but renewables integration is definitely going to benefit your project, or is likely to benefit your project, I should say. There's a lot of opportunity for using on-site solar on these projects to minimise that ongoing cost. So yeah, to summarise, heat pumps are great. They're a great pathway to decarbonisation, really exciting opportunity, and definitely want to support them as much as we can. And designing them well at the start will enable you to save money and support the transition to a more renewable future. That is sort of all I had, so thank you.
Brilliant. Thank you so much, Felix. Great finish. Was designed well at the start. Allows you to optimize this into the future. That's perfect. And it probably hit home with a few people who know their aquatic center type of thermal energy profile. That graph that you showed that showed the average spot prices throughout the day, and the yellow line that peaks in the morning and peaks in the evening, that's pretty much how an aquatic center operates. When they turn on in the morning in the winter, bang, let's heat this place up. And then in the evening as well, trying to keep it warm through there as it gets cooler. So wow, exactly when prices are going up. So yeah, I think you can hit home that message of thermal storage there. David, I've got a question here about, and certainly I understand, Felix, that's mainly from modelling rather than real life case at the moment. David, your aquatic centre does have thermal storage. Are you guys utilising that to take out those sort of evening peaks and things like that at the moment?
That's the idea, for sure. However, we've come up again. We've had some metering issues, and the thermal storage is not being used as effectively as it could be. We've just been looking into that, and that's actually one of our next things, is to optimize that. So it's come up a few times here talking about metering in different ways, but here's another example where there wasn't sufficient metering put in place. We're just fixing that now, and then we'll be able to work out better ways to optimize it, because at the moment it's not being effectively used at all. So we're not seeing those benefits that we potentially could be.
At least you've got that tool. Liz, what's your thoughts on where you're heading with this sort of concept?
Well,
Laura, my apologies. I was looking at Laura.
Well, one of the challenges we've had with our sites is we don't have a lot of space. So trying to incorporate thermal storage, it's a bit like, well, where are we going to put it? Even fitting in the heat pump is challenging for space, and especially at the next pool we're planning to do, well, our other pool, we only have 2. Yeah, just trying to squeeze in the heat pump is challenging enough. So I don't know. I'd be quite interested to explore a bit more, like whether some kind of small, whether it could be cost effective just to even have a small one, and also that idea of like being more closely monitoring when the peaks of energy use are. So we should be raising that with our buildings team.
Absolutely. And Laura, for Inner West Council? I've got Laura right this time.
Yeah, so we are looking at our two next projects, but we have the same issues as Liz, that space is already at a premium. But it's certainly, having already done Ashfield and not incorporating any storage, we're now sort of seeing the limitations of how we can manage the load. But one question that I had for Felix is, so our experience so far is that both from the retailer and the network, the distributor, the tariffs aren't necessarily giving us, in like reflecting what the spot price in kind of any meaningful way yet. Like off-peak is still overnight. There's a little bit of pain for peak periods, but we're not getting the savings that you might see if you're trying to use energy only during the day when it's supposedly very cheap. Do you have a timeline for when we might see that reflect a bit more in the pricing?
Yeah, I mean, we already do have products in the market that can sort of realize some of these savings when you're operating flexibly. And I mean, sort of there's a trial going on with Arena about flexible operation in various sort of facilities that have cooling, like natural storage in their cooling systems or whatever. There's sort of all sorts of industries there. But there are products, and we would be more than happy to chat a bit more about that if you like.
Okay, good to know. Thanks.
And I just, on behalf of swimmers out there, I've got to defend the usual comment about thermal battery of changing the pool temperature. And yes, 0.5 degree, 1 degree, that's substantial. That's fine. But it's such a lovely balance there between the swimmers who are doing laps, please no more than 27 degrees. And if you've got young ones in there, they're saying, please not under 27 degrees. So aquatic centre operators, you enjoy that one. That's that's not for us. We won't go to that one today.
Yeah, I was just going to add, Jared, that a lot of these pools, there's a lot of thermal inertia in the pool hole units. So it's 1.5 billion cubic meters. Some of those programs that that's mentioned can be a shorter duration. It doesn't necessarily need supplementary thermal storage. So you could still get away with doing something without thermal storage, but you're unlikely to capture the full value that we've spoken of.
Indeed, and I've heard things like it's maybe 0.5 degree over 6 hours. So, if you're coming up to that 6 to 8 peak period in the evening and you were at 27 degrees and you just sort of let that run down over a couple of hours while the peak things, and get it down to 26.5 or so by the evening. Yeah, it's surely something to consider there as well. And Stuart, thanks for coming off mute. Up for your presentation next. So we've looked at sort of minimising the OPEX and your energy supply, minimising the CAPEX, and we're going to take another look at that in a moment. But what's if you want zero CAPEX? What's if you want to do energy as a service or heating as a service? We thought this is a really interesting way to really sort of move the needle and help people progress projects. So Stuart, if you could take us through such options that Enel X works on there. And as you're loading up, I'll give you the quick intro. Stuart's been energy consultant for many years and worked with the legends at the likes of Energetics, if I'm not mistaken. But right now he's the Senior Business Development Manager for Enel X, and Enel X does a lot in terms of energy supply for flexible demand and decarbonising solutions. So Stuart, I'll get you to change switch over that display setting and over to you.
How's that, Darragh? Is that coming through full screen?
Looking good,
Beautiful.
thank you.
Beautiful. Okay, yeah, thanks for the intro and thanks everyone for joining. So going to provide an introduction to energy as a service, which is essentially an alternate contracting model that councils can use to decarbonise efficiently with lower risk and, as Jared mentioned, without that hefty upfront capex bill. So just a little bit of background on Enel X, in case you haven't heard of us. We're an energy services provider. We help businesses, large energy optimize, electrify, and decarbonise their energy footprints. We offer a range of decarbonisation solutions, including flexible demand response, on-site solar and battery storage, electric mobility solutions, including charging hardware, software management, as well as electrification of heating. So there's a few points on our our CV. We're consistently ranked as a top energy as a service vendor. We've been in the Australian market for since 2012. We have a retail electricity license, and we also have a sister company, who's a large-scale project developer. So we offer a range of decarbonisation solutions, energy market access, and then innovative funding models to help businesses decarbonise at the lowest cost, which is what we're talking about today. So those decarb solutions, they're all optimised and managed within our virtual power plant, that X cloud you see there, to essentially capture as much value as possible to reduce the costs of these decarbonisation projects. So what's the challenge for councils in their decarbonisation journey? It's just some of them. Access to capital often comes up as a barrier to getting these projects up. They can cost millions of dollars, and they're often competing with other council priority projects, priority investments. So this model can allow that capital to be preserved and redirected to core business projects for the council, with potentially lower risk and higher returns than just energy decarb projects. These new decarbonisation solutions, they're often new technologies, they're evolving, and they carry unfamiliar risks for councils who aren't specialists in these solutions. And currently, councils are taking on a lot of that risk in terms of these new design scenarios and new technologies. And then, of course, resources and expertise. Coordinating complex projects with across multiple vendors can be quite resource intensive, but also expensive. And is this the most efficient use of council resources following this sort of conventional approach? So the conventional approach of councils building, owning and operating their own energy assets might not be the most efficient use of capital resources. So this model, energy as a service, which is an innovative contracting model, essentially help councils decarbonise more efficiently with lower risk and without the need for that upfront capital. So what is it? It involves an external third-party provider, energy specialist, finance, build, own and operate decarbonisation solutions at your aquatic centre. Those solutions will likely consist of heat pumps, thermal storage, flexible demand, on-site solar, battery storage, EV chargers, paired with renewable energy supply, and most councils will already have a PPA in place, but also ancillary equipment to enable those solutions. So mechanical services, electrical supply upgrades, whatever ancillary solutions are required to get those projects into the site, they can be covered under this model. So energy services, e.g. heating as a service, cooling as a service, or renewable power, is sold to the council through a long-term offtake agreement, typically 10 to 15 years, so akin to a solar PPA. So a very similar type of arrangement that we're applying to now heating, the electrification of heat and other decarb solutions, as is being commonly applied to solar PPAs. So the energy services are then purchased on a pay-per-use basis, so dollars per kilowatt hour of heat supplied from that new system, or a combination of a fixed fee, instead of purchasing and owning the asset structure itself. So it's likely to be a fundamental shift in how councils procure their energy and decarbonisation outcomes. It's generally defined by sort of three characteristics. Council receives a guaranteed outcome, whether that's the supply of heat or thermal comfort in the pool or in the centre itself, and renewable energy potentially as part of that, and ultimately it's a decarbonisation service. So the council's costs importantly shift from a CapEx model to an OpEx model, and this unlocks immediate cost savings once the project's in the ground. Based on I guess the performance of the projects and how many of these solutions can be integrated into the site, will determine whether there's an immediate saving, whether the cost of heat is equivalent to what the council was paying for previously, or whether it's an increase in OpEx cost. But you have eliminated the need for upfront CapEx and transferred a lot of the risk to the supplier. But thirdly, demand management. This model shifts the responsibility for the electricity input costs to this, so the new heating system, as well as the operational performance to the provider instead of the customer having to manage that. So a significant sort of transfer in risk and responsibility. So just reiterating some of those benefits: no upfront CapEx. For example, you could take that CapEx for that energy project and repurpose that for another project in the centre, which could enhance patron experience or generate a stronger return at the aquatic centre than the energy project has done itself. Risk transfer: the provider takes on the financial design, construction, performance, maintenance risk. There's availability guarantees within these contracts. So you're essentially looking at a sort of 10 to 15-year warranty on delivered, your delivered energy service. Outsourced expertise. So you can leverage specialist energy expertise to reduce the organisational burden of coordinating these complex projects. And an energy service can sort of decouple your OpEx, annual energy OpEx budget from energy supply variability. So the provider is then responsible for managing the volatility of electricity commodity and demand management, and they're incentivized to drive that as low as possible to then offer a consistent rate of heat or cooling or whatever it may be. And it's a simpler contracting model. I will caveat this: it's simpler in terms of the number of vendors that you're dealing with. I've got a diagram of the next slide. The upfront contracting lift is likely to be more significant than a typical sort of EPC contract, just because it's a new model and it will require executive buy-in and understanding alignment in how this new sort of contracting model works. So this just illustrates the difference from the BAU, typical model of delivering a project to the energy as a service type model. You're essentially shifting the contracting responsibility onto the energy service company, and then you're essentially contracting solely with the energy service company, and then managing equipment supply, installation, maintenance, finance, energy certificates, and so it's certainly not a silver bullet, or it's not going to work for every council, and we recognise that absolutely. We do think it's going to be a very effective model. So some questions to start the conversation and see if this is a model that fit the council. Is the council open to a should be in their normal procurement approach? Can we commit to a long-term agreement? Typically 10 to 15-year term is likely. Are we comfortable not owning and operating our own energy assets and leveraging a third party to do that on our behalf? How predictable are our future energy requirements? I'd say for councils and aquatic centres, that's not huge. That tends to be a huge issue. But any changes to future energy demand will need to be managed under the contract. And finally, could this model help accelerate and de-risk council decarbonisation journeys? All right, I'm running out of time, so I just provided a couple of examples of energy as a service projects that either we've delivered or are delivering locally or internationally. Battery storage as a service, flexible demand as a service, internationally, where delivered heating as a service projects, and also solar and storage, and various iterations of that. And I'll leave it there.
Thank you so much for that, Stuart. And you also, if I add a bit, and bring it back to this community energy upgrade fund, the $100 million for upgrades. This is also addressing one of the main complaints for that fund that I'm hearing is that their councils were wishing that it wasn't co-funding; it was just pure funding, and the government couldn't commit to that. But you're sort of solving that. You say, well, okay, you don't have the capex, okay, let's find a way around that. So that's really great. I'll also add to the model a little bit, and I'm hearing from councils that are saying they may have an operator that's running the plant, running the pool, but that operator's contract may run out in 3 or 4 years' time. And they're nervous to say, well, do we have to retrain the new operator on a heat pump technology they may not be familiar with? And do we have to go through a whole round of optimization with them as well? And I suggest you may well be solving that as well. A question to our councillors there, because I picked up on that 10 to 15 year guarantee, a warranty rather, and this question's come from Darragh. Councillors, are you seeing that from your existing equipment suppliers? I'd suggest not. So that sounds like it's a pretty good offer getting if you're getting 10 to 15 years of warranty there. And maybe if Liz, you've got your heat pump in recently, maybe the warranty is probably not top of mind there for that project. But,
well, it was one thing we included in our RFQ, so we were interested in that. But I mean, it does seem a very good deal from the way it was presented. I guess part of the challenge with all of this, and you've all presented lots of interesting information about the business case, but for councils individually to go through all of that, it is quite a high like a steep learning curve and quite a high transaction cost. And where I could see sort of a value proposition, for any of the ideas you presented, but maybe particularly for that energy as a service thing, is to present that as something that maybe a regional organisation of councils or a joint organisation might procure for councils, so that you aggregate the savings. And we've Laura will be familiar with this, because in South Sydney Regional Organisation of Councils, which we're both members of, for example, we contracted our electricity contract, and we actually got more councils than just our region. We got 25 altogether to procure a longer term wholesale contract. So I think that then enabled us, and we do this with streetlights as well. So we can, if we all chip in a bit, we can fund the sorts of expertise that we have here that can help us look at different models and buy something in bulk, if you like. And we don't all have to go individually through this process. We kind of do it collectively.
Yeah, absolutely, Liz. I think that's a fantastic idea, because you're right. There is some upfront transactional cost in taking the council organisation on the journey of what, and they have to do this regardless with this whole electrification project, but then adding on to that the contractual lift of an energy as a service type agreement. So yeah, I think that's a fantastic idea that the resourcing could be alleviated if that was treated as like a group model.
Stuart, we might see if we can hook you up with a few of these collective councils as well. So Liz, thank you so much. Beautiful. We're a little bit behind time. Stuart, would you mind typing in some of the answers there for the questions, and so people can read that as we move to the next presentation in that Q&A box? That'd be great. So let's move on to our final presentation. So that was the option to completely remove your capex, so to say. Next option here is looking at ways to really optimize that size of that heat pump and look in some sort of hybrid system. And for that, I'd like to call on Brendan Voss. Brendan has possibly one of the best histories you'll come across when it comes to HVAC and chillers, what have you. He's come from the tools, and he's done commissioning and maintenance and all the way to actually running organizations that do complete systems and designs for these sorts of systems. So he comes with an excellent amount of experience here, and he's looked at quite a few studies and performed quite a few for aquatic centres retrofits. Brendan, take it away, and looking forward to what you can share on this partial electrification pathway. It might be on mute there, mate.
Am I off mute now? There we go.
Yep. Just got to start up the Prezzo, and
the problem was I was in Prezzo mode and then I couldn't get myself off mute, so I was doing well. I was working the time we had left, doing a good job. So I guess my job here is to kind of make almost a quick summary. Having listened to some very good information, I just thought I would try and get through, I guess, some early stage thought process of identifying what a partial electrification pathway might look like, which is a very viable option when it comes to CapEx. So start with the real basics right here. And if we have a look at this is the most common type of driver for an electrification project that I've seen anyway, and we've heard is either someone understands the efficiency uplift and is looking for productivity or efficiency, one of those, or their equipment is at end of life and they're looking at a net zero or a fuel shift strategy kind of thing. And that's probably the key ones. And also perhaps there's some operational issues, which has happened quite a few times with old gas plants, never really run properly, or maybe an existing heat pump plant is not running properly and they're just looking for an upgrade. So my famous, most common barrier is CapEx. We've heard that I think almost every presentation today. Whether it be because it's access to funding or whether it be the cost of the actual project, I don't think that matters. I think either way, this is still a very common barrier. So some very common pathways and synergies are here as some examples, and I did marry these up to kind of a little bit of what we heard today, which was talked a little bit about thermal storage, which we've heard about Brimbank, the energy or cooling as a service options, or heating as a service option, should it be in this case, poorly worded on my part, coming from a chiller background, I've just mucked that up. Renewable energy options, there could be grant funding, certificate funding, there's an array of things, but focusing in on partial electrification and the expected outcomes of a project. So this is drawn like this on purpose. Most often in a project, there's some technical and operational reasons why people do projects, but there's a three blocks for financial for a reason, because often the financial argument holds the most weight, I think. So whilst everyone has a say, finance often kind of drives the outcome. So why would we do partial electrification and not full electrification? So one is we can avoid some capital costs, which we've heard quite a bit today. We can avoid new electrical infrastructure, or we can focus our funding on other high impact emissions projects. So for example, we avoid electrical infrastructure upgrades in one place, and we use the money to do another partial electrification project somewhere else, which cumulatively is less emissions. My favorite one is the general thought process of this is lends itself quite well to creative thinking around what the opportunities might be. It encourages finance, operations, technical people all to get involved in actually looking really deep into how the site operates and what the requirements are. We could, Liz mentioned, footprint constraints. So if we weren't putting as big heat pumps in, we can save a little bit of space. We can reduce capex costs with often a very minimal opex cost hit. So finally, the Brimbank story is a risk profile. So the retaining of the boilers for those peak days and while you're ironing out some operations is often a good risk management tool, particularly if you're upgrading. So what's the basis for my theory on this partial electrification? I think is often metering. We heard quite a bit today, and this is very, very valuable here of identifying where we're spending our time. So if we look at a common profile, and almost every operational standard in the world for heating and cooling equipment says we spend less than 1% of the time at peak load, pretty much everywhere. So this is actually blended amongst a few jobs, but shows pretty much 95% of the time we're 650 kilowatts or less, and my peak is 1 megawatt, if we remember back to my original example. So we have quite an opportunity to reduce our costs. So I put that into a really simple financial case, which everyone can kind of read later, but I'm just going to hit some of the key points. I guess my key messages here are there are a number of ways that our financial story becomes better. And the first one here is looking down at the capital cost of 100% electrification being 1.4 million. That includes a power upgrade in this scenario, which is illustrative purpose only, but also comes from an array of projects that I have looked at over the last few years. And then the 98 and 95% scenarios offer substantial capital expenditure savings. So this is very real. Whilst also really, if you look at the OPEX numbers, not making too much of a difference. It's like $4,000 a year versus, $400 for $700 on our CapEx, which is great. We could also look very creatively at our uplift from what would be business as usual, which might be, say, condensing boilers or high efficiency boilers, and show the payback improves as we consider that. So really the premise of putting this up here is to show that by doing only 2 of those thought processes out of the 10 or so we had on the first slide, we've already made our financial case better. And then we have power factor correction. So leaning back to Alan's slide on improving power factor, thermal envelope upgrades on the building. We've got load shifting, we've got load flexing, better metering to control for smart controls. We've got heat recovery, an array of things that we can now consider. And because we have included everybody in the conversation, we should get a very nice wide input. So this thought process lends itself quite well, and I think is probably very valuable in an aquatic centre setting when there is quite a lot of stakeholders, basically, including community. So yeah, just hopefully a nice wrap up and hit on everything that everybody else covered, but everyone else did such a good job that I'll stop talking and letting them get back to answering questions. So
brilliant. Thanks for that, Brendan, and some great examples of showing that just maybe a stepwise approach can save a lot of money and make things happen quickly. And I'll throw it to David on this one, because I know that Brimbank left or still has a backup boiler. And during our visit last week before, David, we looked at, you said that you only used it about 1% of the time over the last winter. Is that's correct?
Yeah, that's correct. 1% or 1.2%. So a really small amount overall, but I guess I'm not, at first I was kind of a bit disappointed, I guess, that we had it. I was like, oh no, this isn't great. This is not a great outcome. One thing I do say is that it's meant that it's given a level of comfort, I guess, to our operations managers and stuff. So the project's been a real success. They haven't, it's come on occasionally, which I think is more of a heat pump control issue than actually a capacity issue without heat pumps. So that I actually expect that will come on a lot less. We're still working out some issues with the staging of the heat pumps. But what it's meant is there's been no loss of service, and it means for our next project, I think we're more likely to invest in that next project, because this one's been a success, and success kind of breeds success. So although I was like, oh, kind of disappointed we have it, in some ways, if it means that the next upgrade and electrification of our next aquatic centre happens faster and sooner, and at the same time we phase down the use of that existing backup boiler, then it's not a terrible outcome, really.
Absolutely. And you mentioned before, you really haven't optimized the usage of that thermal storage yet either. So, yeah, this is going to see 1.2% become whatever, 0.5 next year, and then 0 hopefully the year after that, and really show you how it's done. So, yeah.
I just add to that, Jared, if you do install everything to the peak load, it can be a bit set and forget. So you're not really encouraging this type of conversation where we're actually driving the team to look for those staging improvements and so on. So I think it's actually not a bad incentive, right, to physically go back and look to stop that running. It's just a great story. So sometimes this will be a very good pathway.
Agreed. Stuart, I noticed you popped in a few answers into the questions, and we'll get those out with the slides, that Q&A there. But you did want to answer one of those live, and that was about the how does Enel make sure the system is designed for as efficient as possible?
Yeah, thanks, Jared. I was I couldn't answer after I had nominated to answer it live. So thanks for coming back to that. And cheers for the question, Tony. So yeah, I mean, we are, as the provider of the solution and operator responsible for the input costs, we're incentivized to make that system as efficient as possible in the design, the construction, and the operation, because it means that there's a stronger project return, and so the incentive to drive performance and efficiency on that system shifts from the customer or council to the provider in this instance. So yes, absolutely.
Thanks, Stuart. I expect if you guys have plenty of metering in there, and if someone leaves the pool covers off one night, Enel is there the next day saying, "Oi, let's get them on." Laura, just reflecting on a few of these presentations today, and you've got some upgrade projects coming as well. Any thoughts on some key takeaways where you could apply, or some new thinking that's come through today that you might maybe be able to use in the future projects?
Lots of really good information today. The energy as a service is a particularly interesting one for council. Like, the more of these projects that I do, the more I understand how much expertise we lack as councils, like how complex these facilities are, and that it is a really big ask to for us to get a really efficient system and then know how to run it efficiently. So that was really interesting. Partial electrification as well. We are certainly looking at that in our electrification pathway, not for our bigger centres, but we have a seasonal pool, an outdoor pool, and we would need to upgrade the power supply to fully electrify that. So it makes a lot more sense just for us to reduce the gas as much as possible.
Brilliant. Thank you. Thanks for that reflections there. Now, Liz, anything from you? You've still got one site to upgrade still, and that's on the horizon for you. Any takeaways that can help with the economics?
Yeah, well, I guess lots to reflect on, and as Laura says, it's just like the more you learn, the more you don't know anything about these things. And I think it just really reinforces what I said before about the huge sort of steep learning curve. And you all have presented lots of really useful and detailed information, but really it's just at a quite high level. So to translate that for most councils into practical projects is quite a hurdle. We did dive in with the first pool, and we're going to be diving in with the second. The idea of having maybe partial electrification, and probably share sort of David's thoughts on that, the pros and cons. We have retained the old boiler at Cabarita as a backup, but the challenge we face with the space at Drummoyne is it's a bit like, well, the only good place to put it is where the boiler is, so it may just have to go.
Out she goes. Perfect. Good one. Well, we're just about out of time, so I'd just like to thank our councils for coming again, and return councils. Thank you, Liz, Laura and David. And to our presenters, thank you so much, Grant, Felix, Alan, Brendan and Stuart. And just to round off with today, I'd just like to share a little bit with what's coming up next. If you just bear with me for one moment. We've got we've locked in the date for our next webinar, so we've got 2 more to do, and then we'll feel like we've overloaded you there. And so our next one is on the 8th of February. We think no one wants to do any more webinars from this time of year onwards, and January is very quiet. So we're going to get going again on the 8th of February, and hopefully that'll hit you right in the middle when you're looking at your community energy upgrade. And we're going to take a deep dive into heat pumps. It's going to be technical. We're going to go deep, and so get ready for the technical boffins to come at you, but it's going to be more for you to learn. It'll help you with your decision making. So that's on February the 8th. After that, we also have one on the 22nd, and we're going to look at commissioning and optimization for you. If you're interested in some more A2EP type stuff, there's another webinar on tomorrow. We're going to look at energy-based maintenance and how that can be used rather than just for reliability for equipment, but maintaining to get energy savings. So that one is on tomorrow afternoon. Feel free to join us. All that's left to say is have a very nice afternoon. You'll be left with a survey as you leave today. Thank you so much for joining us. Thank you so much for our presenters once more, and we look forward to seeing you at our next webinar. Thank you all.